The lifespan of THHN and THWN conductors installed in a typical office building environment housed in cable trays and raceways can be estimated to be around 25 to 30 years. This estimate assumes standard operating conditions without any extraordinary environmental factors that could accelerate degradation. Factors influencing the actual lifespan include the operating temperature, the presence of moisture or chemicals, the quality of the installation, and the electrical load on the conductors. THHN and THWN insulation is rated for 90 degrees Celsius in dry locations. However, it's important to consider the incapacitating factors that may apply based on the number of current-carrying conductors in a raceway or cable tray, as specified in the National Electrical Code, or NEC. These deterring factors can reduce the allowable ampacity of the conductors, which in turn affects their operating temperature and lifespan. If the conductors are consistently operating near their maximum temperature rating due to high ambient temperatures or excessive loading, their lifespan will be reduced. In cable trays, proper spacing and ventilation can help to dissipate heat and extend the lifespan of the conductors. Ensure that the cable tray is not overloaded and that there is adequate airflow around the cables. In raceways, the fill ratio should be in accordance with the NEC to prevent overheating. Also, the presence of moisture or chemicals can degrade the insulation of THHN and THWN conductors. Although THWN is designed to be water resistant, prolonged exposure to moisture can lead to corrosion and insulation breakdown. Similarly, exposure to certain chemicals can cause the insulation to become brittle and crack. Regular inspections can help to identify potential problems before they lead to failures. Look for signs of cracking, discoloration, or swelling of the insulation. Check for loose connections or corrosion at termination points. Infrared thermography can be used to detect hotspots, which may indicate overloaded conductors or loose connections. If any problems are detected, they should be addressed promptly to prevent further damage and ensure the safety of the electrical system. When replacing conductors, it's important to select the appropriate type and size for the application. THHN and THWN are suitable for many applications, but there are other types of conductors that may be more appropriate for specific environments. The size of the conductor should be based on the calculated load and the allowable voltage drop. It's also important to follow all applicable codes and standards when installing or replacing conductors. This includes using approved materials and methods, and ensuring that all connections are properly made and tightened. Consider these points for a longer conductor lifespan. Firstly, ensure proper installation according to NEC guidelines, including correct ampacity calculations, deterring factors, and fill ratios for raceways and cable trays. Secondly, implement regular inspections to identify potential issues like insulation damage, loose connections, or corrosion. Thirdly, maintain adequate ventilation in cable trays and raceways to prevent overheating. Fourthly, protect conductors from moisture and chemical exposure where possible. Fifthly, avoid overloading circuits to prevent conductors from operating at excessive temperatures. Sixthly, use appropriate overcurrent protection devices to protect conductors from short circuits and overloads. Seventhly, keep detailed records of inspections, maintenance, and repairs to track the performance of the electrical system over time. Eighthly, consider using high temperature rated conductors such as XHHW for applications where operating temperatures are consistently high. Ninthly, ensure that all electrical work is performed by qualified and licensed electricians. Tenthly, provide training to maintenance personnel on proper electrical safety procedures. By following these guidelines, you can maximize the lifespan of THHN and THWN conductors in your office building and ensure the safety and reliability of your electrical system. Remember that the 25 to 30-year estimate is a general guideline, and the actual lifespan may vary depending on the specific conditions in your building. Regular inspections and proactive maintenance are essential for ensuring the long-term performance of your electrical system. Also, environmental factors in Florida should be considered, such as higher average humidity and the potential for saltwater intrusion in coastal areas, potentially influencing conductor longevity.